this video, we'll be dealing with the codes which are used to find the largest and smallest element in the given array. Now let us analyze the code which is used to find the smallest element in the given array. This is the code which we are going to use to find the smallest element. Here 30h is the starting address of our array and 4bh is the location at which we are going to store the smallest element of our array. Now let's start executing the program. I have initialized the array with the elements 31, 84, 97, 46, 87, 64 and 11. Now we can see that the memory location 4b is currently 0, 0. Now if we run the code, we can see that the 4b location is updated with the value of 11, which is the smallest element of our array. Now let us analyze how this code works. We initialize the register R1 with the destination location value, R0 with the starting address of our array, and R2 with the number of comparisons to be made. As we saw earlier, our array is of size 7, so we are updating the value of R2 with number 6. If our array is of size n, we need to make n-1 comparisons. We'll clear the carry register first. Then let us assume that our first element of array is our smallest element. Now for the recursive process, first we'll update the value of a with the current smallest element in the array. Next we'll increment the pointer R0 to point it to the next memory location and store its data in B. Now we'll compare A and B. If A is greater than B, it means that it is not the smallest element. So we need to update the location of 4bh with B. So we are going to point it to the line 14 with the help of the tag loop 1. This line 14 to 16 will update the value of the memory location 4bh with the value of B. After the completion of the line 16, then we are going to check the value of R2 if it is equal to 0 or not. If it is not equal to 0, then we'll be jumping to count. In the count, the number of comparisons to be made will be decreased by 1, and then we'll again point it to loop if the number of comparisons are not equal to 0. That is, if the number of comparisons to be made are not equal to 0. If the number of comparisons to be made are 0, then we'll be jumping over. Then again we'll verify if the value of R2 is 0 or not. After the verification, it will be pointing to the next line, which is n. What if A is less than B? If A is less than B, instead of going to loop 1 and then coming back to count, we'll directly be proceeded to the step count. And here again we'll be checking number of comparisons to be made or 0 or not, and then the process will be as usual. So at the end of the program, we'll have the smallest element to be stored in the memory location 4bh. The code which is used to find the largest element of array, we need to make one change in the code which is used to find the smallest element. In the line 11, we need to change the function djnz to jc. That is, we need to change it from jump if no carry to jump if carry. Now this code will be used to find the largest element in the given array. In the next video, we'll be discussing how to sort elements in an array. Thank you for watching the video.